Thanks to Tanith and Val Performance for inviting me. It's always nice to present some of my research. So a really brief overview of what I'll touch on today. Basically, I'll look at what is athlete monitoring, how do we monitor our athletes, how does athlete monitoring data actually inform decision making on a daily basis, why do we monitor our athletes, the measurement characteristics of monitoring tools, so an extension of what Stu was talking about before, and as well as the reliability and sensitivity of a few of Val's technologies. So the groin bar, Nord board and force techs within a professional football environment, and then how we actually use information from these sources to inform decision making. So I'll start by discussing what is athlete monitoring. Fundamentally, it's the process of quantifying fitness and fatigue to control the training process. So again, an extension of what Stu was discussing, knowledge of this training dose being completed by the athlete or the external load and their response to this load, which is the internal load, is required to control the process, and this ultimately determines the training outcome. And one training outcome is this concept of athlete readiness, which basically refers to a player or athlete's acute capacity to complete training activities designed by coaches, and then that if that allows them to perform at a high level during competition. So optimal readiness would reflect a condition where a player or athlete has no physical impairment and no excessive psychological or fatigue or distress. So how do we evaluate athlete readiness? Well, obviously we all know that we've got lots of monitoring tools available to us these days, some of which can help us assess the training load or match load completed by the athlete. So external load is one example via GPS technologies, and this gives us information on total distance, high speed distance, maximum velocity, and thousands of other variables. So as we all know, most external load is reported in terms of locomotive load due to validity and reliability, but anyone who watches an AFL game will realise that there's a high mechanical demand of training and comp. So this comes from stoppages, tackling, aerial contests, etc. But there is no valid and reliable measure of this load to date, unfortunately. But certainly, external load provides us with useful information, but ultimately, as I said previously, it is the internal load that determines the training outcome. And this is typically assessed via session RPE, the session RPE method, which basically involves asking a player how about their perceived exertion during a training session or match. And this is combined with the duration to generate an arbitrary figure to represent the total load for that session. The obvious benefit of this method is that it allows quantification of load across any modality, for example, resistance training or cross training. We also evaluate readiness via perceived response to load and other measures. A typical method to do this is through perceptual wellness questionnaires. So these are short psychometric questionnaires completed by players on a regular basis to get their perceptions of their soreness, fatigue, stress and sleep, among other things. And these are typically converted to Z scores or something similar as part of a traffic light system to alert practitioners to meaningful changes in these elements of wellness. But it should be considered that most of these questionnaires are customised for the athlete cohort they're being used with, and therefore they haven't actually undergone proper psychometric validation techniques. So this certainly needs to be considered when we're interpreting changes. But definitely they provide useful acute indicators of a player's perception of their readiness to train and compete. We also evaluate readiness through neuromuscular responses to load and other stresses. Stu covered this extensively, obviously, so I won't spend too much time on it, but basically we know that some neuromuscular performance measures do show relationships with match recovery, injury risk and match running output, but certainly more work is required to establish their sensitivity to acute and chronic changes in training load. So once we've got all this information, we have to actually use it in a practical way on a daily basis. So using an example of an on-field skills session or a main training session of the week in an AFL club, coaches will get together and design the session in line with the tactical and technical components that they want their players to work on for the upcoming match. Followed by this, the high performance team can get together and make their evaluations of individual readiness. And it's here that we consider load completed, perceived response to load, neuromuscular response, age, training history and injury history, among other things. So that's where all this information comes into play. Following this, we deliver the external load to the player. So as Stu said, it's not always about reducing intensity or volume of load. We might increase it. We might take players out of particular drills or put them in particular drills, depending on their response. So we deliver the load to the athlete and then we assess their response to this. So that's all part of the training delivery process. Following this, we undergo a review. So was the actual load what we had planned? Did the players actually respond how we thought they would, better or worse? And did we achieve the tactical and technical aims of the session, as well as the physiological aims of the session? And this is all part of the review process, and ultimately a combination of these factors inform the design of the next training session. And this continues on a recursive loop on a daily and weekly basis. So what's the overall aim of this process? What are we actually trying to achieve by monitoring our players? Are we trying to improve performance? Well, researchers found that aerobic fitness, internal load and external load certainly influence running output during matches, but we also know that increased running output has been shown to have a negative influence on football performance. And what I mean by football performance is separate to running performance. So it's historically been assessed by coach votes, as Stu mentioned previously, as well as statistical indices like champion data rating, etc. So we know that there's a negative association there. So essentially we know that training load does relate to match running output, but it is likely mediated by other preparatory elements. Is it for injury risk? Well, we know that high acute loads and low chronic loads tend to relate to increased injury risk, but we also know that injuries are very multifactorial, and no monitoring system is going to be able to quantify 100% of a player's preparation for a session or a match. So certainly monitoring training load and response may attenuate injury risk, but it's very unlikely to completely prevent the likelihood of an injury. So perhaps it's a combination of both. The overall purpose of monitoring systems is to maximise physical adaptations and minimise the risk of injury. So basically, we want our players as fit as possible, and we also want as many of them out on the park training and then being available for games. So high fitness levels and low fatigue levels equate to high level performance in theory, but this hasn't actually been tested empirically. So ultimately, investigations of training outcomes, performance or injury, with and without monitoring are required for us to actually assess the true efficacy of monitoring systems. We're probably not going to do that because it might put a few of us out of jobs. So until we actually do that, we do know that player monitoring data does inform decision making on individual training load delivery, and this ultimately enhances player readiness for competition. So a combo of internal and external load measures is certainly required to completely evaluate player readiness based on load completed. Perceptual wellness questionnaires are simple and useful indicators of a player's perception of their readiness to train, but more work is required to confirm their validity. Neuromuscular performance tests can be useful indicators of match recovery, match running output and injury risk in isolation, but again, more work is required to assess their sensitivity to changes in load. We know that relationships exist between training load measures and subsequent running output, but certainly not football performance. And lastly, measurement characteristics of validity, reliability and sensitivity should be established specific to the protocols used in professional clubs, as per what Stu mentioned previously. So this is a nice segue into some research that my colleagues and I have done recently, looking at measures derived from the groin bar, Nordboard and Forstex technologies. So a bit of theory to begin with. Validity of testing is the ability of a test to measure what it is actually designed to measure. And there are two forms of validity that are pertinent to athlete monitoring tools. The first being criterion validity, which Stu again spoke about. This is basically our test results versus the gold standard test results. And a good example of this would be a 2K time trial versus a VO2 max test in the lab. So obviously the VO2 max test is our gold standard. but due to time and cost constraints, we can't really do that with 45 professional athletes. So we're going to infer aerobic fitness from 2K time trial performance. And what we'll likely see is the quicker that someone runs a 2K time trial, they're probably going to perform better in the VO2 max test. So that test seems to have criteria and validity. A second, more simple way of assessing validity is construct validity, which is basically our test results versus what we expect the results to be given our knowledge of the construct being assessed. So a really good example of this is perceived soreness as part of a perceptual wellness questionnaire. And we know that previous research has shown that increased perception of soreness are usually following high training loads. So that makes sense to us. More training is going to increase your perception of soreness. So this appears to have good construct validity. So as I said, we can assess construct validity quite simply via some observational research, but criterion validity is more difficult to establish. But nonetheless, athlete monitoring tools should at least possess one of these forms of validity for us to confidently interpret their results. Reliability refers to the consistency in results from one test to another under the same conditions. So this can be assessed via test-retest analysis, which I'll go into a bit further soon. But this basically represents the inherent measurement error that needs to be accounted for when we're interpreting results from a test. So using the coefficient of variation, the typical error, or the smallest worthwhile change. This can be conducted simply and unobtrusively in a normal training environment, as I'm about to show you. And certainly if a change in a test does not exceed this inherent error, we can't be sure that the change in the test result is meaningful. So there are two main measures of reliability that we can get from our test-retest. The first is smallest worthwhile change, and this usually comes from the standard deviation of results from a group of athletes or players, and we times this standard deviation by 0.2, which is said to represent small but non-trivial effects. The alternative way to assess this is coefficient of variation, which arguably is a much simpler measure, and it's just the average between subject change in a measure in a percentage form from one test to another. So certainly both assist in interpreting changes in results, but which one do we use? Well, an example may be a player conducts a isometric adductor squeeze test on the groin bar, and they produce 5% more force on their left limb compared to when they tested last week. So do we know if 5% is a meaningful change? Well, our test CV is 6%, but our smallest worthwhile change is 4%. So a 5% change, we can't actually be sure that this is meaningful because it's less than the CV percentage. And that basically means that we can't be certain that the 5% change is an actual change or it's just because of the measurement error associated with the tool. Lastly, sensitivity. This refers to the extent to which results consistently exceed the measurement error. And they must consistently exceed this for us to consider it sensitive. Both low variation test results and a high CV or poor reliability will always contribute to low sensitivity. And this has historically been assessed, as Stu mentioned, via intervention studies where we do pre and post testing to assess the responsiveness of a cohort to a particular intervention, but this isn't really possible in professional team sport environments due to time and cost constraints. So can we do this another way? We can do this through signal to noise ratio analysis. So this basically combines the variation in a test over a period of time with the inherent test error to produce an index. So in this context, the noise refers to the coefficient of variation or that inherent typical error that I discussed previously. Signal refers to the variation in a measure across any period of time. So for the sake of my research, we looked at between match training cycles, which were between 6 and 8 days, but this can be a week, a month, a training cycle of any length. So by dividing the signal by the noise, we can produce a ratio. And this essentially provides us with a dichotomy. So an SNR of above 1 tells us that consistently these test results exceed the typical error and we can consider them useful or meaningful. If the SNR of a monitoring tool is less than 1, we can't always be sure that the test results that they're producing are going to exceed the typical test error. So how can we do this within an actual training environment? So my colleagues and I looked at the isometric adductor force test used in the groin bar, the eccentric hamstring force test on the NOR-board, and the CMJ test on the ForceDex. And we established noise by doing a test-retest analysis. So 18 players on separate days for the groin bar, NOR-board and ForceDex were asked to complete 2 maximal repetitions on each piece of equipment, separated by 5 minutes recovery. And the difference between the first repetition and the second repetition was considered the individual variation in each measure. And this was averaged in a percentage form to produce a test CV. In contrast, the signal was calculated by averaging individual weekly variation using Hopkins spreadsheets across 23 between match training cycles. And as I said, this was between 6 and 8 days. So in terms of the groin bar, we found reliability to range between 6.3 and 6.7%, whilst at 3 major time points post-match, we found SNRs to be between 1.6 and 2.6. So we also found that there was a likely negative effect of reported adductor groin pain, so subjective pain, on adductor force. So that tells us that this system is reliable, sensitive and valid in terms of assessing adductor strength. Secondly, the eccentric hamstring force test using the NOR-board, reliability was even lower, so it was 2.9 to 4.2%. And at 72 hours post-match, which was when we typically did these tests, the SNR was between 2 and 2.4. So again, we're happy that they're reliable and sensitive. The third was the counter movement jump test on the ForceDex. We chose 5 select measures, these being jump height, concentric mean force, reactive strength index modified, relative peak power and relative peak force, and reliability range between 2.1 and 7% for these. And again, at 72 hours post-match, SNR range between 1.5 and 2.5. So like the other equipment, we're happy that these are reliable and sensitive. So once we've got this useful information, we know that a meaningful change has occurred. How do we actually use it? So one way to use it is through player profiling. So at the start of a major training cycle, for example, at the start of pre-season, our players will undergo a battery of tests on the groin bar, NOR-board and ForceDex, basically to establish their baseline values. And this is basically like any testing protocol. We can use it to assess the effectiveness of our training programs, and we can also use it as a baseline to return to before we allow a player to return to skills and to play. We also look at changes in force production. So we might look at 1 or 2 meaningful changes, so changes that exceed the typical error, as well as a chronic trend. So this might be over 3 or 4 weeks. They might not be meaningful changes in isolation, but overall we can see a downward trend. So this might be coupled with high acute and chronic loads and or perceived soreness or other perceived elements. So this would manifest itself into an acute training modification. So again, we might reduce intensity or volume, or we might increase intensity or volume. We might also decide to rest the player for a day or a week or however long it takes for them to return to a level that we're happy with for them to re-enter the skills program. In a similar vein, force production imbalances can also give us similar information. So again, looking at acute trends and chronic trends, this is particularly pertinent for players returning from injury, which I'm sure some of the other speakers after me will discuss in depth. But this basically gives us an idea of the level that we want a player to return to before we're happy for them to return to full skill sessions and return to play. So we obviously want to reduce strength or force imbalances following an injury before we're happy for them to return to train. So again, this could be through acute and chronic training modification, as well as resistance training programming, so changes to their resistance training. And it also gives us information on their progress of rehab. So how far are they actually away from us being happy with them to re-enter the program? So just to finish, measurement characteristics of reliability and sensitivity can be assessed really easily within a typical training environment through test-retest analysis and signal-to-noise ratio analysis. Construct validity of monitoring tools can be established, again, quite simply through observational research by examining associations between changes in tests and outcome measures. The adductor force test, eccentric hamstring force test and CMJ test all display SNRs of above 1 at major time points following matches. Changes that exceed the CV percentage and the SWC in test results can be interpreted by practitioners as meaningful. And lastly, individual changes in the tests examined in this research, so our adductor force test, hamstring force and counter movement jump, can be confidently assessed within a between match training cycle of 6 to 8 days. Thank you.